Welcome to the session on SAP HANA Security and User Authorization. Here in this session, we will be learning about security perspectives in different implementation scenarios of SAP HANA and user authorization topic. In user authorization topic, we will be learning about roles, privileges, and how users utilize these roles and privileges for performing different activities, and who are responsible for creating users roles and privileges, what are the responsible um, roles and privileges for creating other roles and privileges and assigning them to users, and more about how to reset the master database user, that is system user, password, and more on. Basically, when we want to learn about different implementation scenarios from security perspective, the scenarios would be like, firstly, SAP HANA as a data mart for reporting and analytics, where it is used as a sidecar scenario for reporting purposes. That is, at least some end users have direct access to SAP HANA in this case. This means that user and role management in SAP HANA is not only required for technical users and administrators who regularly log into SAP HANA and do the admin activities, but also for the end users that access SAP HANA directly. And for other security aspects, such as end user authorization for views, SAP HANA security features needs to be used as well. So by this, we mean that firstly, when it is used as a data mart, we will have end users also logging into SAP HANA. So we need to set some security scenarios. That is, we need to implement security scenarios for end users apart from the technical and the admin users who log into SAP HANA. And second scenario would be where SAP HANA is used in a classical three-tier architecture as the primary database for, be it SAP NetWeaver Business Warehouse System or SAP Business Suite systems. So in this, since it is acting as a relational database where client, application server, and database are involved, security related features such as authentication, authorization, encryption, and auditing are located and enforced primarily in the application server layer itself. All right. And the third implementation scenario would be where SAP HANA is used as a platform for providing database and application services to native SAP HANA based applications. Basically, here SAP HANA would act as a platform for new generation applications. Example would be HANA Access application. This SAP HANA Access embeds a fully featured application server, that is web server, and development environment within SAP HANA itself, right? And applications can be deployed directly on SAP HANA Access, which exposes the applications to end users via a web interface. And SAP HANA Access security model is directly integrated with the SAP HANA security model. And users of native SAP HANA applications have direct access to SAP HANA. That is, basically, these web users must exist in SAP HANA. So these users also should be taken care when implementing security aspects. So these are the three implementation scenarios when it comes to security scenario implementation. So basically, after explaining these three scenarios, I would say, as a definition, SAP HANA provides security related features that enable you to implement different security policies and meet compliance requirements for different scenarios and with interfaces. So these would be authentication, RSSO, authorization, identity store, encryption, audit logging. So these are the possible implementations or the security policies which are to be implemented with SAP HANA. And depending on the implementation scenario in which SAP HANA is used, only some of these features might actually be needed. Others might be provided in other architecture layers. And SAP HANA supports standard interfaces to enable integration with the customer security network and data center infrastructures. So, coming to how we do it in SAP HANA Studio, these are the security features which are available. That is user and role management, management of privileges, management of audit policies, and configuration of password policy. So when it comes to user and role management, we create users, assign them suitable roles. So we can restrict users by assigning only the limited roles. And coming to management of privileges, again, we can restrict users by creating privileges to access the database, to do any modification, and also restrict users who will be creating privileges. Coming to audit policies would track any changes done to the database objects. So we can create such audit policies to track the users. Next, finally, the configuration of password policy. For every user created, we assign a password. So the format of the password and the duration of the password, the life of the password, and when the user gets logged. So all such things can be set as a part of password policy. So basically, when it comes to user and role provisioning solutions, we have out of the box connector for SAP NetWeaver identity management, which is used since many years, and we have SQL interface for integration with other identity management solutions, which would be termed as standard based single sign on infrastructures. For example, Microsoft Active Directory. And finally, database audit trial written via Linux syslog. The audit trial that we generate using SAP HANA is written via the Linux syslog on the operating system. You must be aware of Linux syslog and where it is found. And let's move on now. Coming to authentication, SAP HANA database provides various options for authentication. There is direct logon to SAP HANA database with username and password, authentication using Kerberos, that is third-party authentication provider, authentication using security assertion markup language, Bera token called SAML2, and authentication using SAP logon ticket, next to SAP assertion ticket, and authentication using X509 certificates. And all this can be chosen when we actually create the user. When we try to create a new user, we have all these options to be used. So we can directly click on which one to be used and make sure suitable configuration does exist in SAP HANA already, and then proceed to create the user with proper assignment of privileges and roles. So basically, authentication terms as verifying the database user which accesses the database. So basically, for SQL access, username and password, Kerberos, SAML are suitable. For HTTP access, that is for Access Engine. For web users, username and password, SAML, SAP login tickets, X509 certificates are suitable. So you can see the chart here where we have jot down the possibilities, username and password login for SQL and HTTP both are possible. Kerberos, again both. HTTP access goes with SP Nego. SAML 2, yes for both. SAP logon ticket, yes for both. SAP assertion, yes for both. And coming to X509 certificate, it's only suitable for HTTP access and not for all. And when using direct logon to SAP HANA database with username and password, the SAP HANA database administrator authenticates itself when it logins, and when other users are logged in, the database authenticates these users. For some administrative operations such as database recovery, you know that the credentials of SAP operating system admin user is required. That is SID ADM is required. Yeah, now let's get into details of each. Firstly, the Kerberos method of authentication. To implement this, we need to install the MIT Kerberos client software on the host of the SAP HANA database. Make sure this is done. So basically, SAP HANA supports Kerberos protocol for single sign-on. It has been tested with the Windows Active Directory domain Kerberos implementation and MIT Kerberos network authentication protocol. So we need to have these infrastructures, and this is ODBC and JDBC client supported. And here the users are stored in the Microsoft Active Directory, as I said, or in the MIT Kerberos key. So we need to have an Active Directory. A distribution center can be mapped to database users in the SAP HANA database. So for this purpose, especially the user principal name called as UPN as the external ID when creating the database user must be available, and one Kerberos ID can only be assigned to one database user. That's the limitation. And from SPS 7 onwards, we have SP Nego available for SAP HANA Access. And this is the picture how it works. You can see that when a user tries to log on to the system, he has to authenticate himself by receiving a ticket from Kerberos domain controller. So he receives a ticket from here by contacting, and then it tries to log in, and HANA will actually verify this user with the Kerberos domain controller before accepting the login to verify if he is a verified user. Next is coming to SAML. SAP HANA database supports the login of users using SAML as well, as we have learned. And SAML by name is Security Assertion Markup Language, is the XML based standard for communicating identity informations between organizations. The primary function of SAML is to provide internet single sign-on, that is web single sign-on for organizations. The SAML is used to securely connect internet applications. Keep in mind internet applications that exist both inside and outside the organization's firewall, and appropriate firewall setting must be done at the network layer as well. So SAML is now considered as a standard protocol for authentication for SAP HANA, but not for authorization. Keep in mind, it is only for authentication. And generally speaking, we know that Internet SSO is a secure connection that communicates identity and trust from one organization to another. And for users, Internet SSO eliminates additional logins to external resources required. And especially when it comes to system administrators, it improves security and reduces cost. But yes, we should know that it requires a trusted third-party identity provider that can issue SAML assertions for clients, especially the internet browsers. And coming to SAML for access, HANA Access offers web-based tool for security configuration. It has inbuilt tool for making the security configuration. And main purpose of SAML for SAP HANA is to support scenarios where clients are not directly connected to SAP HANA database, but a middle tier application server like web server, Access Engine server is used. And this middle tier application server runs an HTTP server. Whenever the application server needs to connect to the database on behalf of the user, it requests an SAML assertion from the client. Once the SAML assertion is issued by an identity provider after the client was successfully gets authenticated, and the assertion is then forwarded to the SAP HANA database, which will grant access on the previously established trust to the identity provider. So we need an assertion certificate to work with SAML. Here you can see how we configure SAML. Enablement, we have to choose menu bar, Windows Preferences, Security, SAML Providers. There we have to list the SAML providers who will provide the assertion certificates. Because HANA has to verify this assertion certificate with the SAML providers again once the web users who provide these assertion certificates to log into HANA. So for HANA Access, we need to configure several security related aspects of SAP HANA Access applications. This can be done in the configuration tab under Access INI. And this is the screen of the Access administration tool where we can do the SAML configuration. It's a detailed step and we have various SAP notes to explain this, which can be referred. Now let's move on to understand SAP logon ticket and SAP assertion tickets and how users get authenticated using this tickets. So no doubt HANA should be configured to accept this logon and assertion tickets. So if we want to integrate an SAP HANA system into a landscape that uses these tickets for user authentication, we must configure SAP HANA to accept them as well, right? So SAP HANA validates incoming logon assertion tickets against certificates signed by a trusted certification authority called CA, stored in dedicated trust store of SAP HANA. This trust store must contain all root certificates used to validate logon and assertion tickets issued by the users. So appropriate root certificates are necessary here to verify the logon or assertion tickets. So using these root certificates which verify the logon assertion tickets, the user named in an incoming SAP logon ticket must exist as a database user, then only will be authenticated. The database user also must be configured for authenticating using logon or assertion tickets. This also is possible. And how we do it, everything as I said is possible using the user editor of the SAP HANA Studio. And that was about the authentication methods that exists in SAP HANA database. Now let's move on to authorization topic. So coming to authorization topic, we know that every user who wants to work with the data of SAP HANA, that is use the objects of SAP HANA for modeling or any development, and also users who want to do admin activities like monitoring, performance analysis, and also for transport activities like export, import of objects, and yeah, also users who want to do replication setups, monitor the replication, create new replications of tables. So all these users must have proper roles and privileges to log into database. They are termed as the database users. And also for activities like backup and recovery. So authorization would consider privileges and roles for users. What are privileges? Privileges would restrict the access to data and perform operations. So can be granted directly or indirectly to users. It's basically termed as separate for design time and runtime objects. We have something called as design time and runtime objects in SAP HANA. So when design time objects get activated, they become the runtime objects. So when they are still as the design time objects, they carry different set of privileges. And when they become runtime, they carry different set of privileges. So appropriately, we need to assign these privileges to the users using them. Coming to roles, roles are nothing but group of privileges. They are a set of privileges which are bundled for a particular set of activities. And standard roles which are available are like monitoring, modeling, backup admin. We have some more for different activities like catalog read and more, backup operator. So it is possible to create roles as design time objects in repository for transport as well. And using these roles, we give uh, users the set of privileges for the activity that they have to do. Okay, now let's understand about how we achieve encryption within SAP HANA. What is data transfer encryption possibility available with SAP HANA, and what is volume encryption, and how do we configure these encryption mechanisms in SAP HANA? So in order to protect against security breaches or outside attacks, companies prefer to protect data using encryption. So that is where encryption topic comes into picture. So they are done for both data transfers, as I say, data transfer encryption and data stored, that is volume encryption, storage encryption, and achieved using SSL method for data traffic between database and clients and between hosts in multi-node. So we need to set up SSL method of encryption between clients and database and also between different hosts in a distributed system. And it uses AES-256 algorithm for data stored in volume for volume encryption. And coming to data transfer encryption, to support the different SAP HANA scenarios and setups, SAP HANA has different network communication channels, right? Different types of basically channels used for external access to SAP HANA functionality by end user clients, administration clients, application servers, and for data provisioning via SQL or HTTP. And next is channels used for SAP HANA internal communication within the database or in a distributed scenario for communication on between hosts. And channels used for network communication between the primary site and the secondary site in system replication scenarios. Basically for replication scenarios, and connections used for administration purposes, connections for data provisioning, connections from database clients that access the SQL interface of the SAP HANA database for development purposes, doing any development activities, and connections from HTTP or HTTPS clients, or it may be outgoing connections also. So all these connections are to be encrypted. Or alternatively, what we can do is set up VPN tunnels. It happens at the network layer where VPN tunnels are set up at both the parties, both the ends, so that encryption can be achieved using them. Data transfer between them gets encrypted automatically. And these are some of the standard ports used for different interfaces. SQL MDX goes with 157 for SAP support, that is remote support SAP router must be configured. And the port used is 09. Coming to HANA Studio, it uses 1128 or 1129. And HANA Access uses 80 instance number or 40 instance number for HTTP and HTTPS accordingly. So for SQL SAP, it starts with 3 instance number and then 15 or 7. For SQL MD, SAP support starts with 3 again, the standard ports. And what's the configuration procedure now? So at server side, SSL must be installed. And to enable HTTPS, SSL certificate must exist. Certificate hierarchy and certificate for SAP HANA database server are made available, and deploy corresponding root certificate on all the client sites to get authenticated. And finally, configure settings for SQL DBC, that is JDBC based clients in indexserver.ini. These are the steps. And how to enable SSL for users. So whenever we add system to HANA Studio, we have to select connect using SSL. So that means connection enables using SSL. And whether certificate and hostname in certificate must be validated or not can also be selected when we add the system to the studio. Coming to data volume encryption and uh, knowing about how to configure it. See, basically, page keys are valid for a certain range of save points and can be changed by executing SQL statements, as we know. And after persistence encryption has been enabled, any initial page key that existed is automatically generated. And page keys are never readable in plain text, which we must understand, but are encrypted themselves using a dedicated persistence encryption root key. So here it uses an encryption root key for the page key. Okay, whenever an initial page key is to be encrypted, it is done by the root key. So basically, data volumes encryption ensures that anyone who can access the data volumes on disk using operating system commands cannot see the actual data because they are kept encrypted. And we use AES 256 CBC algorithm to encrypt data in pages, as I said, which makes use of a root key. And data when loaded to memory is kept unencrypted. So there is no need to decrypt in memory. So data can be directly accessed, which can avoid lags or any delays. And pages are encrypted and decrypted using encryption page keys. As I said, they are 256-bit persistence encryption page keys. And root keys for this are stored using the SAP NetWeaver secure storage in the file system SSFS functionality. And no encryption of data backups, traces, redo logs are available as of now. So basically, appropriate root keys must exist for encrypting the page keys. That's what we learned here. And we know that during startup, administrators interact, but again, they interact with the database. That's what we have to understand here. And they also have to be authenticated. If required, we can set up an encryption even for these users to access the database data. And how do we enable this configuration setup? So data volume encryption on disk can be configured using Studio or SQL commands. There are two ways to set this. And after activating encryption, new data that is saved to disk will be encrypted starting with the next save point. And existing data, what happens, gets encrypted slowly in the background. And this can run for long time depending on the size of the HANA database. And once after the process has completed, we can use the database in full-fledged. And this monitoring of encryption progress can also be done using SAP HANA Studio. So basically, when it comes to setup, we should understand that the root encryption key for data volume encryption is always created automatically during installation. So that is when we create the HANA instance, the root key gets automatically generated. And further, to enable data volume encryption, what we have to do is under system security folder, we have to click on security. There is an option to click on security and we have to choose data volume encryption there. Do the appropriate configuration so that data volume encryption is initiated. And coming to understanding about SSFS master key, as I told you, it uses SSFS functionality. So here DP API is used by the secure internal credential store, which is needed in some scenarios such as data mart access, that is smart data access to securely store additional user credentials, basically for enabling access to remote systems. So when SAP HANA uses SSFS to protect the root encryption keys, which is used to protect all encryption keys used in SAP HANA system from authorized access, we can enable users getting authenticated using these encryption keys. And there are two types of root encryption keys for data volume encryption and other is internal data protection API, as I said, DP API. And once uh, these root encryption keys are in place, we can enable the encryption of data volume. So here what happens is there are keys like data volume encryption happens through save point specific key and secure credential store key does also exist in SAP HANA database, and these are controlled by the root keys for data volume encryption and internal data protection API root key. So these root keys will control the other root keys, and these root keys are internally controlled by SSFS master key, which is again present in a database. And there is a command line tool called rsec ssfx, which is used for changing master key using SID ADM user. Now coming to auditing. The auditing feature in SAP HANA database allows to monitor and record selected actions performed in your system. That is, any changes done to the database can be tracked, be it configuration or be it database objects. It can be tracked using the auditing mechanism present in the SAP HANA database. Make sure if you want to track, it is enabled because audit logging is not enabled by default. Basically, it is required to restrict unauthorized access to data, restrict unauthorized data changes, configuration changes. And what are the events that can be audited? Changes to user authorization, creation and deletion of database objects, authentication of users, changes to system configuration, access to or changing of sensitive data. So all these can be audited using the auditing mechanism. And the log for audit, as I said, is done along with the syslog, Linux operating system logging system, which is a secure storage location for the audit trial because not even the database administrator can access or change it. That's the reason it is stored inside that. And this auditing can be configured in SAP HANA Studio or using SQL statements. Note, auditing can be enabled and disabled for the entire database, not for individual objects or schemas. So basically, when auditing policies are enabled, an audit entry is created in the audit trail. And this audit trail, as I said, is written to Linux syslog or to another option called internal table. There's an internal table which gets the recording of this audit trail. And when these audit policies are enabled and the actions in the database are logged thereafter. And the database table, that is the internal database table which stores this audit trail, is underscore sys underscore audit schema of the SAP HANA database. This table is present inside underscore sys underscore audit schema. And audit entries are only accessible through the public system view, that is audit underscore log. Make sure this system view is used to see the audit trials. And we can do select operations on this view. And for doing select operations, there are specific privileges needed like audit admin, audit operator. And yes, what are the changes? We know that changes to user authorization like creating drop of users, creating drop of role, grant revoke SQL privileges, other privileges like analytical system and analytical privilege drop creation, and any changes to structure privilege. All this can be audited. And also various database objects changes can also be audited like tables, views, procedures, and any write read access to data can also be audited like select, insert, update, delete, execute. And coming to configuration, changes to system configuration, that is anything in the ini file, installing license key, and setting the system license can also be audited, and authentication of users can also be recorded here. So only actions that take place inside database engine can be audited, make sure. And if the database engine is not online, when this action occurs, it cannot be detected and therefore cannot be audited at all. So some prerequisites does exist for activating the audit policies. That is, we need the audit admin and infile admin privileges for the user who sets this. Basically, permission to create, alter, activate, deactivate, and drop any audit definitions is done using these privileges. And for enabling the auditing, this is the option that we have. We have to set this parameter to true and false for disabling. And we know that audit policies are stored inside the database, and where stored in database catalog public audit policies. So when we do a select star on this public audit policies, we can see the set of audit policies created. And these audit policies can specify any number of actions to be audited. See, this is a picture of how you can check the status of auditing. Once you click on the security, under the security folder, you can see whether it is enabled or disabled, and you can also see which trial target is used to store, whether it is syslog or database table. As I say, internal database table under schema sys audit or the CSV text file. And this is the entry of the audit policy. Now let's move on to know more about user authorization. As I said, we need database users, administration users, and end users who are to be authorized to log into database. And this user management can be done using SAP HANA Studio, and also another option is using SQL commands. So basically here we will be explaining about how to handle user management and user provisioning. That is how we manage users, privileges, admin roles, modeling roles, and how do we reset passwords. And here basically we will talk about end users, modelers, DB admin users, and the standard database administrator user, system user. So as I said, we can use HANA Studio, STB SQL, and other option is, which I'm going to talk about now, is SAP NetWeaver IDM, which is Identity Management Connector. So basically, SAP NetWeaver Identity Management 7.2 SP3 contains a connector to SAP HANA database called as IDM connector. So the process of setting this is detailedly explained in an SAP note. Like it talks about how the user management can be configured using SAP NetWeaver IDM, which can be referred and used. So basically, using these tools, you can make use of these tools for creating, deleting user accounts, assigning roles, setting passwords for users, resetting passwords, uh, activating users, deactivating users. So all these are possible. And coming to user types, as I said, end users, modelers, DB admin. What are end users? End users are business end users reading reports using client tools, for example, Microsoft Excel. Any end user who connect to SAP HANA database for analytics and generation of reports. And modelers who create business models and reports using SAP HANA Studio. Modelers who basically use the modeling environment, modeling perspective in SAP HANA Studio. And coming to DB admin, database administrators or basis administrators, HANA administrators who operate and maintain the database in the life cycle of the database. And also they can do export import of objects, can set up replication using the HANA Studio. And now learning about how to manage users and roles. So basically this figure shows how roles are created, how privileges are assigned to roles, and then we create users, assign these roles to users. See, the workflow goes like this. First we create users, uh, what roles they require must be created first, then the appropriate privileges must be assigned to roles, then create the users, and then assign these roles to users. So using the role management, we first create the roles and assign the existing privileges. or create new privileges prior to creating roles, and then assign these privileges to roles, and then create users, assign the roles to these users, and also we can assign individual privileges to these users, and then we can start. So basically, uh, the roles are created using a command called create role, and we can provide the role name, and then once the role is created we can assign privileges to roles, and then create users. We can choose the authentication method and other user settings, and then further provide the roles. We can use the grant role name to user command, or if you want to revoke, we can use revoke role name from user command appropriately. No doubt it can be also done apart from the SQL, like grant, revoke. We can directly log into the user GUI, and then under the roles tab, privileges tab, we can assign the roles by selecting them. So what are privileges? When accessing the SAP HANA database using a client interface, access database data is supported by set of privileges, by few privileges which are defined, that is predefined. And these set of privileges are system privileges which authorize execution of administration activities for the entire HANA database. And next is object privileges which authorize access to data and operations on database objects in the repository. Analytical privilege which authorize read access to analytic attribute calculation views at runtime and provide row level access control based on the dimensions of the relevant view. So access to views are done using analytic privilege. Package privilege which authorize access in the repository, that is basically in the modeling environment at design time. And application privileges which authorize access to SAP HANA Access application functions. And finally, privileges on users. Like privileges on users are SQL privileges that users can grant on their user. So basically giving privileges to other users for doing SQL activities. So using this, user can allow other users to debug SQL script code that is being executed. Basically procedures. So finally, the SQL privileges, which privileges to control the execution of SQL commands, which are a group of system and object privileges. So any SQL statement execution can be controlled using these SQL privileges. Now let us learn about few of the important privileges here. Coming to system, which are responsible for users and roles, catalog and schema management, analytics, auditing, system management, data import and export are the set of activities for which system privileges would be relevant. Some standard ones are user admin, role admin for user and management, create schema, data admin, catalog read, alter system, import export for importing exporting objects, alter system for altering the system configuration, catalog read for backup operations, reading the database objects, data admin again for database object access, create schema for creating new schemas. So these are the set of standard system privileges and few important ones. And some more are like monitoring, modeling, backup admin, backup operator. All this can be used. Coming to analytic, as I told you, it is for referring to attribute analytic calculation views. So basically, to access field from attribute view, field from attribute view used in analytic view, private dimension of analytic view, attribute field in calculation view, combination of the above, all the above, single value range, ion list access. So all this can be controlled using analytic view. Coming to application, it's basically for SAP HANA Access application users, where the standard ones are grant application privilege, revoke application privilege, procedure in the sys repo schema. So we grant these for any users which uses the web server to talk to SAP HANA database. And we can also revoke these application privileges. Coming to privileges for users, as I said, it is assigned to other users for doing SQL operations. That is on SQL script called procedures. So this is for debug or SQL script operations, as I said. So, and the standard one is attach debugger option. So once we try to create an user, or for the users created, we can just navigate into users GUI where we do the setting for the user, and there under privileges for users we just have to checkbox this attach debugger, and then we are set to grant this. Now coming to roles, we have understood privileges and different set of privileges available and what each one is used for. A role is a collection of privileges, as I said, can be granted either to an user or it can be granted to an existing role itself. So a role can also be a group of roles in this meaning. And the type of roles, as I said, are design time and runtime. Coming to design time, these are created by the technical user sysrepo, and they are not directly accessed to a database user. It is created by sysrepo, that we must understand. These are transportable between systems. So if you want to use it in another system, it is transportable. We can just export and import in another system. And execution of stored procedures to grant. We basically execute certain stored procedures to grant these roles. And users with access to these procedures can grant, revoke any design time role. Coming to runtime. Runtime is for direct access to database. And again, this is granted or revoked by a database user only. And note, if any user gets deleted, all roles granted by this user are revoked. Say, for example, a particular role A is granted by user A to user B. And if user A gets deleted, this role A, which was assigned to user B, also gets revoked. So make sure before we delete an user, we identify what are the roles assigned to different users by this user and make appropriate changes to retain those roles for the particular users. And some of the predefined roles are public, monitoring, modeling, SAP internal, HANA support, which are basically used for admin and modeling activities. So that was about roles. Now let us learn about system user password reset. In SPS 9, we have this procedure available. In the previous support package stacks, we have a console mode where we ran the alter user command to reset the password. But coming to SPS 9, we have an option to use STB index server with reset user system, and then it will prompt for the new password. So basically the scenarios would be like if the system user password is lost, we can make use of this procedure, or if we restore a system using a backup from another system, and if the system user password is unknown, we can make use of this procedure. So to do this, firstly we have to log in with the operating system admin user, that is SID ADM user, and we have to stop all the running processes using STB stop, and then execute STB name server ampersand. That is, we activate only the name server and inactivate all other server processes. And then we start the STB compile server executable with ampersand. We activate this. See, we should make sure we are inside the STB instance exe directory where we can find all these STB executables. And once the compile server is started, we proceed ahead using STB index server executable to reset the system user password. And this is the password that we can set. Once we issue the reset user system option with STB index server, we are prompted to set the new password. This would be the basic password anyone would set. We can use any standard password based on the password policy that we follow for our environment. And once the password is entered, this gets activated. And further on, we see that index server gets shut down after resetting the password. So we have to manually start the HANA database. So before starting, make sure the name server and the compile server, which were started in the background using ampersand, have to be killed. So identify the PIDs, the process IDs of these two processes, that is name server and compile server, using ps-ef option, and then kill these processes, and then we can manually start the HANA database, and then we are good to use the system password what we have set. So next is about password policy. As I said, password assigned for users can follow certain standards based on the password policy. So passwords for any username assigned for authentication can be subjected to certain rules called as password policy. Note that we cannot deactivate the password policy once enabled. And password blacklist can also be created. Here you can see which is a list of password words that are not allowed as passwords. So we can blindly set something like something with name. For example, rocket, which cannot be used as a password. So anything like we can set any name which are not to be used as password in the password blacklist, and they are not to be assigned anymore. So if any user tries to set this password, he will be prompted saying this is part of the blacklist and cannot be set. So basically, password policies will define the password quality, the complexity, and the security compliance that should be followed. So basically the length, complexity, see here you can see the password length to be number of characters, and what are the required combination, whether lowercase, uppercase, numeric digit, whether special characters must be included. And we can do the log settings, and we can set other settings like if there are failed attempts, how many failed attempts are allowed before logging the user, and password lifetime, what are the minimum maximum lifetime, and last used password, where if you want to reset the password, last 5 used password cannot be used for the new password. Lifetime of initial password, once the password is reset, it has to be changed within these number of days. And maximum duration of user inactivity, if an user created is inactive for this many days, the user gets locked. A notification of password expiration. So if the password is expiring 14 days from now, I will be given an alert to change my password. Okay, these are the password policy settings that can be set. And coming to blacklist, we see here that blacklist for forbidden terms, that is forbidden words which are not to be used as passwords. And this password blacklist in SAP HANA is implemented with table sys password blacklist in sys security schema. And this is owned by system user only. So with this, we have now understood how to set or the scenarios of security implementation, and what do we mean by authentication, and what do we mean by authorization, and how they are followed.